Yes, sir.
अच्छा ठीक है. The sucrose is an example of a disaccharide. Student, sucrose is made from two units of monosaccharides. One is D plus glucose, other is D minus fructose. This question has been asked in the paper. Then on hydrolysis, write the products of the sucrose. So we are saying on hydrolysis, sucrose will produce two molecules of monosaccharides. One is alpha D plus glucose, other is beta D minus fructose. Second question is that how the two are joined with each other. These monosaccharides are joined with each other through a linkage which we call as a glycosidic linkage. Glycosidic linkage means two monosaccharides are joined by an oxide linkage formed by loss of water molecule. So this is a point to be noted because this question has been asked in the paper 1 mark question. So I think we know कि as we have shown in this diagram, student, this is the structure of the sucrose, the sugar which you are eating. Carbon 1 of the alpha D glucose and carbon 2 of the fructose, they are linked through oxygen, oxide. This is called oxide, oxygen. And this is where OH group and OH of this, what happened? Water was lost, minus H2O, and this oxide bond is there. This is called glycosidic linkage, students. And important point to note down is this question was, is it a reducing sugar or not? Now, this is an important question. Sucrose, what is the meaning of a reducing sugar? I told you there are two types of sugar, reducing and non-reducing. Reducing sugars are those students which will give the positive test for which test we are doing, students, for the reducing sugars. What test they are giving? You already know that the test of the free aldehyde group. If aldehyde group is free, then they will give those tests which are there for aldehyde. So these sugars, there is no free CHO group now, or neither there is a free ketonic group. Therefore, they cannot give Fehling solution test, tolerance, or whatever test which aldehydes give student. In this case, therefore, students, what we will find that this sucrose is a non-reducing sugar because there is no free CHO or CO group. Clear? This is
Yes,
no
sir.
non-reducing sugar, student, because the linkage is at C1 of glucose and C2 of fructose. So both CHO group and CO group of the ketone, this is ketonic CO group and this is the aldehyde group, they are not free. They are not available, students. They are bonded now. They are not available, they are not free, therefore it cannot give the test of a reducing sugar. Therefore this question has been asked in the paper, which disaccharide is non-reducing, student? Sucrose. Another important property of the sucrose which is asked is, student, it is called invert sugar. Why the sucrose is called invert sugar, student? This is an important question. That this sucrose, actually sucrose is optically active. It is dextrorotatory. It is dextrorotatory, students. But when it is hydrolyzed, what happens? There is a inversion of the, what we find, it becomes from dextro to levo, student. The sign of rotation changes. Dextro means it will rotate the plane polarized light towards clockwise direction. And levo means it will rotate the plane polarized light towards the anti-clockwise direction. When sucrose is hydrolyzed, student, what happens? There is a change in the direction of the rotation, or sign of the rotation changes from plus to minus, and that is the reason it is also called invert sugar. Why this happens? Now this is an important question. This is an important question, student. This is an important question which we have to discuss. What I am saying, that why is this a called invert sugar, student? This question has been asked. I will try
Yes,
my
sir.
best to give as many questions as possible which have been asked in the paper, so that we know that in every biomolecule chapter what type of questions are coming. We should be prepared with this. In this disaccharide itself, in the case of sucrose, I have asked you so many questions. All these questions were asked. Again, I will give you what questions I am asking student, because whatever questions are important, they must be discussed.
Yes, sir.
For exam, we have to do the questions. That is the main thing. So students will find that paper very easy if they will listen to me very carefully. I am going to discuss large number of questions in every chapter. Question number one, student, which I said, products, write the products of hydrolysis of sucrose. ठीक है? This you know.
Yes, sir.
What are the products of hydrolysis of sucrose? Tell me fast, 30 seconds. It is written on the screen. What are the products of hydrolysis of sucrose? D plus glucose and D minus fructose.
Yes, sir.
Okay. So we have written it D glucose and D fructose. That question is answered. Question number two, students. Where is the linkage? ठीक है? Linkage of glucose, D glucose and D fructose in sucrose. In sucrose. Tell me what answer you are writing for this. The linkage is at what position? C1 of carbon 1 of in the exam I will write carbon 1 of alpha D
Yes, sir.
glucose and carbon 2 of beta D fructose. ठीक है? Clear? Nothing more than that.
Yes, sir.
You can write this in the paper. You will get 1 mark. Question number 3 is sucrose reducing or non-reducing sugar. What is your answer? Fast, 30 seconds, student.
Answer something.
What is it? Reducing or non-reducing?
Um, 2 minutes, sir.
Non
Yes, sir. Sir, it's non-reducing, non-reducing.
non-reducing. Why?
Hmm.
Because carbon 1 and carbon 2, carbon 1 of glucose and carbon 2 of fructose, beta fructose are linked, ठीक है,
Yes, sir.
through glycosidic bond or linkage, ठीक है. So therefore there is no free CHO or ketonic group.
Yes, sir.
Those two groups are not free, they are tied up, therefore it will not reduce. Failing solution, tolerance reagent or other test which you do for aldehyde and ketone students, these tests are not given. Question 4. What is glycosidic linkage, student? What is glycosidic linkage? You have 30 minutes to answer the question fast. Important question has been asked many times.
Answer, sir.
What is glycosidic linkage? When two
Glycosidic
monosaccharides
linkage.
are joined by an oxide linkage by the loss of water molecule, what do you call this? Glycosidic linkage.
Linkage, yes, sir.
This oxygen you see, how it is formed, the OH of this and OH of this, they combine, water is lost and this is oxygen. So there is an oxide linkage between two monosaccharides, between the two monosaccharides, oxide linkage, student, with the loss of water. This is called glycosidic linkage. In polysaccharides also there will be glycosidic linkage, and there will be more than 2 units of monosaccharides which will combine, student, which will be joined. More than 2, even in we will see in starch and other, more than 100 molecules of glucose are joined, 100 to 1000 molecules. See, that is why they are called polysaccharides. They are giving large number of glucose molecules inside the body. Starch, you know, starch, it will give large number of glucose molecules. Another question, question number 4, you answered. Question 5, student, why sucrose is called invert sugar?
Yes, sir.
This question has been asked in paper. How many questions I put? So many questions in sucrose. So the sucrose is dextrorotatory, but when it hydrolyzes in water, it will give glucose and fructose. The rotation of fructose is minus 92.4 degree, and that of glucose is, the rotation of fructose is how much? Minus 92.4 degree alpha value rotation, and the rotation of glucose is plus 52.5 degree. This was plus, this rotation was plus, mean dextro, this is dextro d, small d. What will happen? Minus is more than plus on hydrolysis, so the net result will be, it will become from D to L on hydrolysis. It will convert from D to L, student. Then it will
Hmm.
become, the rotation sign will change after hydrolysis. Yes or no? This minus
Yes, sir.
is bigger than positive.
Hmm.
This was positive rotation, but on hydrolysis it produced two monosaccharides, one with plus 52.5 degree rotation, other with minus 92. What will be the addition of the two? It will, the sign of rotation will become negative.
Hmm.
Sign of rotation in the
Become
polarimeter
negative.
will become negative, student.
Yes, sir.
From positive sign to the negative sign means inversion of configuration, means inversion. That is why it is called invert sugar,
Yes, sir.
because the sign of rotation changes on hydrolysis. Okay? All the questions answered. Sucrose. Now I'm coming to the second disaccharide, which is maltose, student. Maltose. Now the question, first question. What are the two monosaccharides
Yes, sir.
which are which are joined, or which make the maltose? Two monosaccharides. On hydrolysis, which two monosaccharides will be obtained? Hydrolysis is done by acid or enzymes.
Hmm.
It will give alpha D glucose. As you can see, this is made from which? It is
Yes, sir.
going to give you, what is it giving? It is composed of two alpha D glucose units. Alpha D
Yes, sir.
glucose plus alpha D glucose.
Hmm.
It is composed of two, what two? Tell me
Okay.
what two? Two alpha D glucose units.
Yes, sir.
Alpha D glucose units. This is one glucose alpha, this another glucose, and
Hmm.
they they will be linked by what? Glycosidic linkage will be there. In all these cases, what linkage is there? Glycosidic linkage, student.
Yes, sir.
That is why it is a question for the paper. They will ask you what is a glycosidic linkage. Again and again I am repeating this because this is very important. Has been asked repeatedly, what is a glycosidic linkage, students? when two
Hmm.
monosaccharides when two monosaccharides are linked through oxide linkage by the loss of water molecule, that is called glycosidic linkage. So another question is, where is the linkage in this? The linkage, where is the linkage? Question number 1, question number 2, this question number, this was another question, student. 1, 2, 3. What are the two units of which maltose is composed? What is your answer?
Yes, sir.
Alpha D glucose.
Okay.
Two units of alpha D glucose. So, question number 3 is, where is the linkage in this case? Where is the linkage, student? Where is the linkage? Where is the linkage? As you can see, the carbon 1 of 1 alpha D glucose
Hmm.
is linked with which carbon? Which carbon number is this? What is this? Carbon number 4.
Yes, sir.
Carbon 4 of another alpha D glucose.
Okay.
So this is important question always. They ask you the linkage at which carbon, linkage at which carbon, student. That is what makes all the difference.
Yes, sir.
These are, they are combining. but at different positions, linkage is taking place. Because there are OH groups, these OH groups can condense with the loss of water molecules. There is an oxide
Hmm.
linkage. But at which carbon? When the position will change, the compound will change. So you are getting maltose. Now, question 4 will be again, is it a reducing sugar? Is it reducing sugar, student? What is your answer? Maltose. Is maltose a reducing sugar? Yes or no?
Hmm.
That is our
Yes,
question.
sir.
Here you see that linkage is at C1 and C4.
Huh.
So what will happen? The aldehyde group is present at which point in glucose? At position 1.
Hmm.
In CHO group is at C1 carbon, student, in glucose. Therefore, first C1 will be not free, but the
Yes, sir.
linkage is at C4, student. In the case of the second glucose, what will happen? The CHO group is free. Therefore,
Hmm.
student, it will be showing properties of a reducing sugar. Answer is that maltose is a reducing sugar,
Sugar.
students.
Yes, sir.
Question: Sucrose was a non-reducing sugar
Hmm.
because
Yes, sir.
the carbonyl group of fructose and CHO, they were joined, linked. They are not free. But here
Hmm.
C1 carbon is used, but C1 4 carbon is used in the second glucose. So the CHO group is at carbon 1. In the second case, it is available. Second glucose molecule, it will be available. Therefore,
Yes.
it will show properties of a reducing sugar, student. Maltose will show properties of a reducing sugar. So all the questions of the maltose is answered for our
Yes,
exam.
sir.
No more than that. It is made from two alpha D glucose units. On hydrolysis, it will produce 2 units of alpha D glucose. The linkage is at C1 alpha D glucose and C4 alpha D glucose, and it is a reducing.
Yes, sir.
4 questions answered. Next, lactose, student. Another disaccharide which I am talking is lactose. Lactose is present in which? Tell me where lactose is present.
So milk.
Yeah, you are drinking milk. Which sugar is present in the milk, student? Which saccharide is present? Saccharides are sugars. You know milk has sugar
Yes,
itself.
sir.
You
Glucose.
are adding one more spoon of sugar and eating it. What is the use of that? That is sucrose. Sucrose is what will sucrose do in the body? It will go and it will produce glucose and fructose inside your body. So
Yes.
why you want to add a sugar? Nothing, no use, because milk already have lactose. Milk has got lactose, students. Which sugar is present in milk? You are saying lactose. ठीक है? You know the answer. Now question 1 answered. That milk contains which sugar, which saccharide? You are answer lactose. ठीक है? Anything can be a question in the paper. Question 2. ठीक है? What is it? What is lactose composed of? What is lactose composed of, students?
Yes, sir.
It is a disaccharide. There will be 2 monosaccharides. Which 2 monosaccharides are present? We
So
have.
glucose and galactose.
Which are those?
So glucose and galactose.
Glucose. Which one? You have. See here what is written. Beta D.
Yes, sir. Beta D.
Beta D galactose and beta D
Glucose.
glucose. These are the 2 monosaccharides. Student, you should remember it. 1 mark question. It has been asked in the paper. On hydrolysis, they will produce what? Beta D galactose and beta D glucose. And
Okay, sir.
question 3, again I said, tell me where is the linkage? What linkage? I talk of glycosidic linkage.
Sir, C1 of glucose and so C1 of galactose and C4 of glucose.
See, be careful in answering. This is the point. What is your answer?
Sir, carbon 1 of galactose and carbon 4 of
Carbon 1 of beta D
galactose.
galactose. Beta D galactose, very good. And carbon 4 of beta D glucose. If you answer this, 1 mark, you get 1 mark. You can see the questions in biochemistry is fully scoring chapter, but you have to remember, students. You have to learn it and make sure that you know it before you go to paper, because you will get full marks in this chapter. Only small questions are there.
Yes, sir.
I'm going to discuss every question which can be asked. There's no more questions after this. You have defined what is glycosidic linkage. You have defined where is the linkage. Carbon 1, carbon 4. Okay. Carbon 1, carbon 4. All this is important, student. Uh, this you can see the structure. That is why we have drawn the structure to make the clear. One more thing. What is the difference between glucose and galactose? If I compare glucose and galactose, student, how they are, what is the relationship between glucose and galactose? What is the relationship? This is O, this is O, this is H, this is H. You have OH, you have OH. What is the position of carbon 1, carbon 2, carbon 3, where is carbon 3? This.
Yes, sir.
And carbon 4, what is the position in carbon 4? See the difference? Rest is same. They were differing
Yes,
because
sir.
this OH and this OH, they have formed oxide bond. How the oxide bond is formed, student? You see that you had OH and H, student. What is this position? Carbon 1. This is my carbon 1, student. And what he is showing? H and OH. He is showing like this. H on the top, OH must be on the lower. Then what is happening? They will lose water. OH and H will lose water, student. And then oxide linkage will be formed as O. Okay? This is at carbon 1, this is at carbon 4 position. Therefore, the two are differing at which position? At carbon 4 position.
Yes, sir.
What will be they? Just I told you about epimers. What I told you, epimers. What is the relationship between galactose and glucose, student? What is the relationship between galactose and glucose? They are epimers because they differ at C4 configuration of the OH group.
Yes, sir.
We told you about epimers. That is why we told you epimers. So further question, final question in this. Is lactose a reducing sugar or non-reducing sugar? This is a very favorite question in the paper. Reducing or non-reducing sugar? Tell me.
Sir, lactose is reducing.
Reducing.
Yes, sir.
Why? It is a reducing sugar. That is the correct answer. What is the reason for this? You have to tell in the paper. You will get 1 mark for that.
Okay, sir.
The reason is because the linkage is at C4 and C1. C1 is the CHO group, and here the linkage is C4 in the second molecule. In the glucose, the CHO group is at number 1 in the glucose, so that is free. That will be free, student. Therefore, it is a.
So your voice is breaking again.
So the 3 disaccharides I told you till now. Which one I told you? Sucrose. We have told you sucrose, students, and we have told you maltose and lactose. Out of these, only sucrose is non-reducing, and these two are reducing sugars.
Sir, voice is breaking.
Okay, let me see the network, but I will continue. We will give you the recorded video of this also. You will get the recorded video. You can keep on making the notes.
Sir, hello.
Hello. Hello.
Hello.
One
Yes, sir.
second.
Sir, I can't understand anything, sir.
1 minute, 1 second
Sir,
only.
I can't understand anything.
Okay. चल क्या माउस आवाज आ रही है कि नहीं अभी?
सर आपकी आवाज क्लियर नहीं आ रही है.
अच्छा कोई बात नहीं, मैं अभी अभी देखता हूँ इसको. चल रही इस पे कैसे देखें? एक मिनट. Okay, what I am trying to do that here what I have student 4 or 5 questions which have been answered.
Yes, sir.
For sucrose is non-reducing, maltose and lactose are reducing sugars. Now further we are coming to the polysaccharides. Can you listen to me? Yes or no?
Yes, sir. Yes, sir. Yes, sir. I can listen now.
Okay, polysaccharides. Now what we are talking is polysaccharide students. Polysaccharides are those which contain large number of monosaccharide units joined together by glycosidic linkages. Always I am using the word glycosidic linkages. This is a important question. Important question, student. Glycosidic linkages.
Yes, sir.
Monosaccharides are linked through what bond, student? What linkage is there? Is an important question. Monosaccharides
Yes,
are
sir.
linked through. Monosaccharides are linked through, student, glycosidic linkages.
Yes,
Are
sir.
linked through glycosidic linkage, which we have already
Linkages.
told you. What is a glycosidic linkage? The OH group of one monosaccharide and OH group of other lose water molecule and form an oxide bond, and that is what we call as glycosidic linkage. So you know polysaccharides are the ones which are our main source of food, student, food storage, and they are major biomolecules and long chains of carbohydrate molecules and
Yes, sir.
composed of several smaller monosaccharides. Mainly, they function as important source of energy in animal cell and form a structural component of plant cell also. Plant cell also. So polysaccharides are
Yes, sir.
important for a student. The most important polysaccharide you are a very starch. Now there will be a question on this in the paper. Starch is a, first of all, what is a starch? It is a polysaccharide.
Yes, sir.
That means it will contain large number of glucose units, large number of glucose students. It is a polymer of alpha glucose. It is a polymer means there are large number of students glucose units. Which glucose unit? Alpha glucose. Question number 2.
Yes, sir.
What is the monosaccharide of which starch is made up of alpha glucose? So you are eating so much of glucose when you are eating starch. And it is present in vegetables, roots, tubers. And there are two components of the starch. Starch has got two components, student. Again, question is coming here. What are the two components of the starch? What are the two components of the starch? One is called amylose, student. One of the component of starch is amylose. This is water soluble.
Yes, sir.
About 15 to 20% of starch is amylose. This is water soluble. Important points to be noted. Amylose is water soluble, student. And what is chemically amylose? It is nothing but what we say unbranched chain. Unbranched branched chain student, मतलब straight chain. It is not branched, unbranched chain. ठीक
Yes,
है?
sir.
With 200 to 1000 alpha D plus glucose units. See how many glucose units are there?
Yes, sir.
More than 200. If you are eating starch, how much glucose you are getting? Too much. They inside the body, they will give more than 200 to 1000 glucose molecules. I think if we test our body, everything, so much sugar will be there in our body because we are eating so
Yes, sir.
much of starch and everything. You are eating cereals, tubers, vegetables, everything is giving starch. And starch has got 200 to 1000 alpha glucose units. So much sugar will be produced in the body. And
अच्छा
after that,
सर आप
people are eating.
सर आपकी वीडियो कहते फिर से हो रही है कहते हैं कि आवाज और बढ़ाऊंगा वीडियो प्लीज
अच्छा कोई बात नहीं, ये हम इसको खत्म करने वाले हैं। ये मैं इसका रिकॉर्डेड भेज दूंगा अगर कोई डिफिकल्टी
हाँ
है।
सर तो से देखूंगा क्योंकि बीच में कहता है काफी गंदा हो गया था ये ऐसा
अच्छा
वाला
अब ठीक है,
केमिस्ट्री
अभी मैं नेट को 2 बार चेंज किया है, इसीलिए लोड
हाँ
कुछ ज़्यादा लग रहा है यहाँ पर नेट का। तो मैं पूरी कोशिश कर रहा हूँ, इसको ख़त्म करूँगा। इसको हम ख़त्म करने जा रहे हैं। तो
यस सर
उसके बाद ये इसमें मैंने जो बताया वो, अब इसके अंदर जो क्वेश्चन आने वाले हैं स्टूडेंट कोर्स टाइप के, कि जो व्हाट इज द एमाइलोज, इट इज कंसिस्टिंग ऑफ अल्फा डी प्लस ग्लूकोज यूनिट्स 200 to 1000, और वेयर इज द लिंकेज इन दिस। हमेशा क्वेश्चन लिंकेज पे बहुत आता है। वेयर आर द अल्फा डी ग्लूकोज यूनिट्स लिंक्ड?
यस
अल्फा
सर
डी ग्लूकोज units, they are held together, they are held together by C1 and C4 glycosidic linkage student between alpha D plus glucose units,
यस सर
as you can see here. C1 C4 C1 C4 ये आगे कंटिन्यूड रहेगा, दिस विल कंटिन्यू, दिस लाइन मींस कंटिन्यू हाउ मेनी 200 to 1000. So glucose units, alpha D glucose units are producing straight chain amylose.
यस सर
Amylose जो है, it is about 15 to 20% and water soluble component of the starch. This is the first component. Second component is amylopectin, important because in the paper this is expected question. The second
यस सर
component of starch is student
हाँ दीदी शायद
amylopectin. What is amylopectin? It is first 80 to 85% of starch.
यस सर
80 to 85% of starch. Again, it is made up of alpha D glucose units. Everything is alpha D glucose units, student. And here there are two things. You can see two types of, it is a branched chain. Now this is a big difference. This question has been asked. That was unbranched. This is branched chain polymer. Polymer means there will be large number of small units. Polymer, when I use polysaccharide, there will be more than 100 glucose molecules. Now this is a branched chain, students. There are, you can see that, student, first chain I have shown. Here the linkage is between C1 and C4. In the alpha D, it is a branch chain polymer in which first chain is formed. Student. The glycosidic linkage is at C1 and C4. This question will be asked in the paper.
यस सर
This one, what is the linkage? C1 and C4 glycosidic linkage. But branching occurs at which carbon? Branching occurs at which carbon? You can see carbon 1 and carbon 6. Branching is between, this is carbon 6. This is carbon 6 number, student. This is carbon 1.
Mm.
But we have to say that chain is formed with glycosidic linkage at C1, C4. Branching occurs by C1, C6 glycosidic linkage.
Yes, sir.
This is the most important part because there is a question, that first question, question number one, what are the two components of starch? What are the two components of starch, students? What we said, there are two. First one was the one which we showed you,
Mm.
amylose. You have amylose and amylopectin.
Yes, sir.
Then they will ask question two, what are the differences between the two? Important, has been asked in the paper. Give the differences between amylose and amylopectin. So you are, what you can see, this is a branched, that is unbranched. This is, that was only about 15%. This is 85% student, and this is water insoluble. Another important thing,
Yes, sir.
water insoluble, and amylose is water soluble, amylopectin is water insoluble. This is,
Mm.
amylopectin is branched, this is unbranched. Very important point. This difference is asked so many times. Then question number three, he is asking, where is glycosidic linkage in
So looking again.
amylose, and where is the glycosidic linkage in amylopectin? Amylopectin. We know what type of linkage is there. We have already said what type of C. Here you are having straight chain C1, C4 carbon of alpha D glucose, and here there are two, chain is formed by C1, C4, and branching is at C1 and C6, alpha D, what type of alpha D plus glucose. So alpha D
Mm.
plus glucose units.
Okay, sir.
So this ends the important types of disaccharides and polysaccharides, which is an important question for the paper. So we have discussed all the important questions. Then we will meet you in the next class. This
Okay, sir.
mostly a lot of questions which are coming in the paper have been discussed. There is some problem. We will send you the video which you can
Okay.
listen of the things which you cannot listen from this, but more large number of questions have been discussed. Okay, then we will see you in the next class, students.
Okay. Thank you, sir.
Okay, bye bye.